Tesla Bot Gen 3 is impressive. Human-level dexterity, improved walking stability, AI-driven task learning, mass production ambitions. But while Tesla refines household robotics, China is rapidly advancing combat-capable humanoid and quadruped robots for military deployment. And that changes the conversation completely. Because robotics leadership in 2026 may not be defined by who can cook breakfast. It may be defined by who can deploy at scale in extreme environments. So the real question becomes, is Tesla winning the consumer robotics race while China dominates the industrial and defense robotics race? Or are we watching two completely different strategies unfold at the same time? Today we break down
finalizing the design of Optimus version 3. And that really is going to be a very remarkable robot. It will have essentially the manual dexterity of a human, so meaning a very complex hand.
What makes Tesla Bot Gen 3 impressive? What China is doing in advanced combat robotics, and whether 2026 belongs to consumer robotics or military-scale robotics. If you want serious, grounded analysis on Tesla, robotics, and global tech competition, subscribe to the channel right now. We break down strategy, not headlines. Because robotics is no longer science fiction. It is geopolitics. Let us begin. What makes Tesla Bot Gen 3 actually impressive? Before we jump into China's combat robotics advancements, let us give Tesla proper credit. Because Optimus Gen 3 is not a toy. It represents serious engineering progress. Keycap 1 human-level dexterity focus. Tesla is heavily focused on solving the hand problem. Why does this matter? Because the human world is built for human hands. Door handles, tools, kitchen appliances, factory components. If a robot cannot manipulate objects precisely, it cannot function in real environments. Optimus Gen 3 reportedly improves finger articulation, force sensitivity, grip precision, object recognition. That moves it closer to real-world usefulness. This is not flashy combat robotics. This is practical robotics. Keycap 2 AI learning advantage. Tesla's real weapon is not hardware. It is AI training data. Millions of Tesla vehicles generate real-world video data daily. That feeds neural networks that can transfer learning principles to robotics. Optimus is not manually programmed for every task. It is trained. That difference is massive. Training allows adaptability, task generalization, continuous improvement. This makes Optimus scalable beyond one narrow function. Keycap 3 mass production ambition. Unlike most robotics companies that build limited research units, Tesla is targeting thousands of units, then tens of thousands, eventually millions. That manufacturing ambition changes everything. If Tesla applies its automotive production philosophy to robotics, cost compression becomes possible, and cost compression determines adoption. Keycap 4 consumer and industrial utility focus. Optimus is being positioned for factory support, repetitive industrial tasks, household assistance, elder care support. This is long-term labor market disruption, not military shock value. Tesla's strategy is economic, not tactical. Now here is the turning point. While Tesla builds general-purpose economic robots, China is rapidly advancing robotics in a different direction. And that direction is military and tactical deployment. Before we move into what China's combat robotics programs are actually doing, take a moment to subscribe if you have not already. The next section shifts from consumer robotics to global power dynamics. China's combat robots, a different strategy entirely. Now we shift gears. Because while Tesla focuses on economic and consumer robotics, China has accelerated development in military and tactical robotics. And the strategy is fundamentally different. This is not about folding laundry. This is about battlefield deployment. Keycap 1 quadruped combat robots. China has showcased robotic dogs equipped with autonomous navigation systems, terrain adaptability, mounted surveillance systems. In some demonstrations, weapon integration. These systems are designed for reconnaissance, urban warfare scenarios, high-risk military environments, border patrol, and tactical operations. The goal is not household convenience. It is operational advantage. And military robotics advances quickly when backed by state-level funding. Keycap 2 Humanoid Military Robotics Research. Chinese robotics firms and research institutions are also working on humanoid platforms focused on load carrying in difficult terrain, autonomous coordination, swarm robotics integration, AI-assisted decision support. Military robotics does not require human friendliness. It requires durability, stability, and operational capability under stress. That allows different design trade-offs. Speed over elegance, armor over aesthetics, mission focus over versatility. Keycap 3 Centralized Acceleration. One key difference is deployment philosophy. Military robotics can scale faster because testing environments are controlled, deployment decisions are centralized, public consumer trust is not required. Tesla must satisfy safety regulators, consumer expectations, insurance frameworks, public perception. Military robotics operates under a different rule set. That changes timeline velocity. Keycap 4, but these are not the same market. Here is where clarity matters. China's combat robotics and Tesla's Optimus are not direct competitors. They serve different domains. Tesla targets economic productivity and labor markets. Military robotics targets strategic advantage and defense readiness. Winning one domain does not automatically win the other. However, the perception of technological leadership can influence global narratives, and perception shapes investment flows. Now pause for a moment. If 2026 becomes the year when military robotics visibly advances faster than consumer robotics, does that mean Tesla is behind? Or does it simply mean the goals are different? Before we move into the real strategic comparison, make sure you are subscribed. The next chapter will examine who is actually winning and how that depends entirely on which metric you use. Who is actually winning in 2026? Now we reach the emotional headline question. Is China winning? Or is Tesla still leading? The answer depends entirely on how you define victory. Keycap 1 If victory means military deployment speed. If we measure by tactical deployment, combat readiness, rapid field testing, centralized scaling, then military robotics programs can move faster. They operate under state-level funding, fewer consumer restrictions, mission-driven urgency, controlled environments. In that metric, China's combat robotics push can appear ahead, because battlefield robots do not need to win public approval. They need to function. Keycap 2 If victory means economic disruption. Now change the metric. If victory means replacing repetitive labor, scaling to millions of units, reducing global labor cost, integrating into factories and homes, then Tesla's approach targets a far larger economic impact. 1 million Optimus units deployed in factories would influence manufacturing productivity, supply chain efficiency, labor allocation, global production cost structures. That kind of shift changes economies, not just tactical environments. Keycap 3 Scale versus specialization. Military robotics often specialize. They are designed for specific missions. Optimus is designed for general-purpose functionality. General-purpose robotics is harder, but it is also more scalable. If Optimus reaches high-volume production, cost reduction below $30,000, reliable multitask adaptability, the economic footprint becomes enormous. Winning the consumer and industrial robotics market may ultimately influence more people than winning combat robotics demonstrations. Keycap 4 Perception versus long-term impact. There is also a perception layer. Combat robots generate dramatic headlines. They look futuristic. They feel powerful. Consumer robots look slower and less dramatic. But economic impact is often quieter than military innovation. History shows that long-term influence usually comes from productivity gains, cost efficiency, manufacturing dominance, not only tactical deployment. Now ask yourself this carefully. Which is more transformative long-term? Robots that change battlefields, or robots that change global labor markets? Before we move into the final conclusion, take a moment to subscribe if you have not already. The final chapter will bring this discussion into clear perspective without emotional exaggeration. Did China just steal 2026? Or are we watching two different races? Now let us end this the right way. The thumbnail says, China wins. But here is the honest conclusion. There are two completely different races happening at the same time, and they are not competing in the same lane. Brain Race 1, Military robotics acceleration. China's rapid development of quadruped tactical robots, weapon-integrated robotic platforms, autonomous coordination systems, shows serious momentum in military robotics. That momentum is real, and it matters strategically. Military robotics evolves under different incentives: national security urgency, centralized funding, deployment-first mindset, faster field testing cycles. That allows visible progress quickly. If the question is battlefield robotics dominance in 2026, China is clearly pushing aggressively. Robot face race 2. Economic robotics disruption. Tesla's Optimus Gen 3 is not built for combat. It is built for labor replacement, factory automation, household assistance, elder care, logistics support. That market is vastly larger economically. If Optimus reaches reliable general task execution, cost below mass adoption threshold, scalable production volumes, AI learning expansion, the economic impact could exceed military robotics by scale alone, because replacing millions of labor hours globally transforms productivity. Balance scale the real difference. Military robotics is about tactical advantage. Optimus is about economic leverage. Military robots change specific environments. General-purpose robots change entire industries. Those are not the same competition. They are different categories. Now here is the deeper question. Which path scales faster long-term? State-driven tactical robotics or market-driven economic robotics? Military robotics can move fast initially, but economic robotics, once cost curves fall, can explode in adoption. That is when true global impact happens. Rocket the 2026 reality. China may dominate headlines with combat robotics demonstrations. Tesla may dominate industrial conversations with scalable humanoid production. The real winner in 2026 will not be determined by viral videos. It will be determined by unit production numbers, deployment scale, cost reduction, real-world adoption. Robotics is no longer about who looks futuristic. It is about who scales sustainably. Now I want your honest perspective. Do you believe military robotics will define the next decade? Or will economic and household robotics quietly reshape society more profoundly? Comment below and share your view. If you want balanced analysis on Tesla, global robotics competition, and long-term technology strategy, subscribe and turn on notifications so you do not miss our next deep dive. And in the next video, we will break down whether Tesla can realistically produce 1 million Optimus units per year before 2030. Thank you for watching. Think beyond headlines. Think scale. And I will see you in the next one.